Hello everyone, welcome back to our channel Code Heaven. Today we have an exciting and informative tutorial lined up for you. We're diving deep into the world of serverless technology using Amazon Web Services, specifically focusing on AWS API Gateway, Lambda function and DynamoDB. Whether you are a developer, an entrepreneur, or just some curious about the latest in cloud technology, you are in the right place. So without further ado, let's jump right in. So in Lambda functions, we have clients. Clients will access our Lambda function through HTTP API, and Lambda function will get the data or write the data to DynamoDB. DynamoDB is a NoSQL database service provided by AWS, which will be sent back to the client. And all of these services are serverless. We won't be hosting any servers in the cloud, so we won't be paying any money for the cloud and for the service virtual service in the cloud. So at first, let's in the world of cloud computing, serverless doesn't mean that there are no servers involved. Rather, it means that you as a developer don't have to worry about managing the servers. AWS takes care of all the heavy lifting, allowing you to focus solely on your code. That's pretty cool, right? So let's start setting up our API gateway. Let's get our hand dirty by setting up our API gateway. This is API gateway is actually the entry point to our application, which defines our resources, methods, and security settings. So by the end of this segment, you'll have a full functional API gateway up and running. So you'll have to log into AWS console first. Once you log in, then you're going to have to search for API gateway. So it's this one. Once you click this one, this window will appear. Once this window appears, there are a couple of API types that you can choose from, and these are HTTP API, WebSocket API, REST API, and REST API private. Okay, I'll define. So what are the purpose of these types of the HTTP API? So first, HTTP API is low latency and cost effective REST API with built-in features for OIDC, OAuth2, and native core support. So this is a very cost effective REST API solution. So another one is WebSocket API. So this is used for like real-time applications like chat application or dashboards or game applications. Another is REST API. So these both look quite similar, HTTP API and REST API, because both are for the REST API. But this REST API has some additional features, like it has we can gain complete control over the request and response along with API management capabilities. And another one is REST API for private, so which can be accessible only within VPC. For this, today we are going to make a simple CRUD application using serverless technology. So everything would be managed by AWS. We will not be making any servers today, and we will also be making a front end. The front end part will be making in React.js, and we will host the front end on S3 bucket as well. So let's create our first HTTP API. Let's create build. Let's give the name. The name would be http CRUD dash API. Let's create it. Next and next. So it's time to review. API name is this. So there's no route and stages at the moment. Let's create it. Okay, so this is going to be the endpoint that we'll need to call from our front end. Okay, so once we create this, we'll need to go to routes and create different methods like get, post, put, delete. So this is a place where we are going to, let's create the get method slash items. Our get method is created. And we can integrate this with our Lambda function, but we haven't created our Lambda function yet, so we can't create that right now. So let's go to routes. Let's create some few methods, and then we can go to Lambda function and create a Lambda function. Let's create get by ID. So let's items slash ID. Let's create one post items. Let's create delete items slash ID. So we're going to delete by ID. That's why we need that ID part as well. So we got get, post, get by ID, and get by delete. So that's pretty much it. After that, we'll need to create a Lambda function, but before that, let's create some DynamoDB as well. So as usual, you will have to search for DynamoDB and click this DynamoDB services here, and this will bring you to this dashboard, and then you can create table here. Let's give it name http CRUD http CRUD. Let's make dash CRUD, and the partition key, let's just put ID. Partition key is like the primary key in the relational database. Here we say it as a partition key. And you can also give a short key. Short key is somewhere you can sort from, sort from. So it's an optional field. For now, we'll just keep it simple and just put ID and create table. Okay, it's creating our table called http CRUD. Now, okay, now that's active. Now let's go back to Lambda function. You can go to Lambda and create function, author from scratch. Let's give a name of the Lambda, http dash CRUD dash function. And in the runtime we can choose different languages like .NET 6 and C#, Go, Java, Node.js, Python, Ruby, and so on. For now, let's just click Node.js, since most of the developers, they know JavaScript. No matter which language you use, most developers You'll have to know the JavaScript, so it's a universal language. That's why I'm choosing Node.js at the moment, but it's your choice. You can choose .NET, Python, or any other language that's listed in here. Now let's create function. Okay, our HTTP CRUD function is now created, and so by default it will give us this piece of code. If we test this, let's just give some test name and save. And now if we test it again, it will say hello from Lambda. That's this code. But now what we have to do is, in this handler function we'll have to write all the CRUD. We'll have to call the DynamoDB. We'll have to call the DynamoDB API from here. For that we'll need DynamoDB client. We'll need to call the SDK of the DynamoDB, and we're gonna call all the methods like we'll have to add and delete and post the items into DynamoDB. For that I have some built-in code with me. Since to save the time, I have already written the code. I'm just going to copy that code and paste it in here. So in this code what I'm doing is I'm importing DynamoDB client from AWS SDK / client DynamoDB, and after that I'm also importing DynamoDB client, document client, scan command, put command, get command, and delete command. So these are the commands that we can use to scan or add or get or delete items in the DynamoDB, and these are coming from AWS SDK / live DynamoDB. At first we create instance of DynamoDB client and put this instance inside DynamoDB document client here, and we'll just give the name of the table. This table name should be exactly that we created here. So my table name in the HTTP -CRUD, so let's just put that name over here. Let's just paste that here. And after that, usually the best practice for the Lambda function is to create a separate Lambda function for delete, get, and put. But to make this tutorial simple, I'm going to write all the codes in this Lambda function. So at first let's see what this code is doing. Switch event dot route key. So whatever the event that's coming over here, so whatever we send through our API gateway, it will come from this event, and in the event we are looking for route key, and if the route key equals to delete /items and ID, then it will go to delete command, and delete command will send this ID of the event, and as soon as we send this to DynamoDB, it will delete the data from the DynamoDB. Similarly, we do the same for get item by ID, get all items. It will scan all the items in the DynamoDB by using scan command, and put. And remember, instead of put we are going to use post, so let's rename this one to post. Okay, now and then we are just catching if there's any exceptions occurring in this code. Sometimes it could be network failure or any other errors, so we'll need to catch those errors. And finally we are writing the status code, body, and headers. So it's saying change is not deployed, so we need to deploy this code before it takes some effect. Okay, now it's successfully updated. Now we go back to our API gateway and attach integration. Create and attach integration, lambda function and function CRUD function. So this is the function, lambda function that we made, and let's create it. So we're gonna have to do the same for all the methods. Lambda function. So apart from lambda function, there are other options here as well, like HTTP, URI, private resource, and so on. So this HTTP URI is if we have any other URI that we want to point this API gateway to, then we can choose this HTTP URI. Similarly, there are other functions as well, other services, but now we are just going to use lambda function. Let's do the same for get. Okay, now everything is done. All these endpoints are mapped to our lambda function. Now let's deploy. So before deploying, we'll need to create a stage. So stage like dev or prod, and which environment we want to deploy. Right now I am going to make a dev environment. Now that's created. Now deploy once again and select dev and deploy to stage. Okay, now that's deployed. So this is the endpoint URL that we are going to invoke. So to test this endpoint, we will need Postman. So let's bring in Postman. So let's make a new endpoint, new URL here. Let's paste this and get /items. Now if we click send, yeah, it's giving us some error. Authorize, it's regarding some permission error. So we'll need our lambda function to give access to DynamoDB. So for that we'll need to go to lambda function, configuration here. So by default it has given us this role name, so we'll need to edit this, and instead of this use an extend role, create a new role from AWS template. Let's give this name called http -crud -role, and the name is simple microservice. So this simple microservice permissions will give simple CRUD permission to us to DynamoDB. So let's choose this one. Now it's saved. So our role name is now changed. Now let's try to invoke our API once again. Let's click send. Okay, now it's giving us an empty array, which is some progress. Since we don't have any items in our database, that's why it's giving us an empty array. Now let's create a duplicate tab, and instead of get, let's do post, and in body we'll gonna need to send some items, JSON item, like let's create an object. Let's send ID of 1. Let's an item with ID of 1. Let's say let's give name, let's say test. Let's give something like price, like 200. So now DynamoDB we have only one column at the moment, it's just ID, right? But we are giving here name and price column as well. Let's see if DynamoDB creates these name and price for us. Let's send, and it's saying post item 1. And if you go back to get, now it should give us that item. You see, that's created. Let's create some more, like 2, test 2, and 300. And let's create a duplicate of item. Let's get item by ID /2. Let's just get 2. Okay, that's coming. Now if you go to our DynamoDB, let's click DynamoDB and let's click this explore table items, and as you can see there are 2 items in this DynamoDB. This scan would like generate all the data from the DynamoDB. You can also query, you can query by some items as well here, but for now let's just do scan. As you can see, both the name and price column that we didn't create at the beginning, but DynamoDB created this for us. Now let's create one more endpoint, the delete endpoint as well. Let's duplicate this one. So instead of get, let's put delete. Let's delete item 2. Okay, it said deleted item 2. Let's search for item 2. Nothing is coming. Let's get item up to, nothing is coming. Let's get all the list of the items. So there's only one item. So as you can see, our API endpoint gateways are working at the moment. Let's scan this in DynamoDB as well. So there's only one item at the moment. So our CRUD application is done from the AWS console, and we have successfully tested using Postman. So right now, without using any servers, we have managed to make a working application by just using serverless technology of the AWS. So now that we have created the API gateway, Lambda function, and DynamoDB, it's time for us to consume these API and show this functionality in a front-end application. And for the front-end application, I'll be using React.js. So we'll be consuming these API endpoints in the React.js, and I'll show you how we can do that, how we can consume these API endpoints in React.js in my next video. So stay tuned for my next video to consume these APIs. Guys, if you like my videos, don't forget to like, share, and subscribe this video. This will really motivate me on making more videos like this. Thank you, and see you till the next video. Thanks.